Grade 11s, we are looking at our third day of trigonometry of obtuse angles. So we are going to just recall briefly what we looked at yesterday, special angles that we would see often, and are going to apply then today to obtuse angles. So let's review those for a moment, please. 30 degrees. Proportionally, the sides for a 30-degree triangle would be smallest would be 1, the 2 to root 3. At least proportionally, that would be the ratio of the sides for a 30-degree triangle. So then, our sine of 30 degrees, opposite over hypotenuse, is a half. Cos of 30 degrees, adjacent over hypotenuse, is root 3 over 2. And tan of 30 degrees, opposite over adjacent, is 1 over root 3. The same triangle, but referring to the opposite angle, the 60-degree angle, the same proportion of sides in that triangle, but the ratios are different because we're looking at the 60 degrees. Sine of 60 degrees opposite over hypotenuse is root 3 over 2. Cos of 60 degrees is a half, and tan of 60 degrees is opposite over adjacent, which is root 3 over 1. The 45-degree triangle, proportionally, is 1, 1, root 2. And so that the sine of 45 degrees, opposite over hypotenuse, is 1 over root 2. And also cos of 45 degrees, adjacent over hypotenuse, is also 1 over root 2. Tan of 45 degrees is opposite over adjacent, 1 over 1 is 1. You need to have those recorded on that sheet I gave you and or in other cheat sheets that you might use and refer to. We're going to use those angles and their value to develop trig ratios of values larger than 90. We're going to impose these angles on the Cartesian plane. So first of all, we're going to talk about how we set these up. We have an initial arm, which is always on the x-axis. So we start facing this way. Initial arm. And we rotate counterclockwise. And this rotation we'll call theta. So we will rotate counterclockwise. Although students don't use those kind of clocks anymore. And this theta is the angle of rotation. This arm at the top is called my terminal arm. It sounds deadly, but it's just where you stop. So we start here, we rotate through the angle of rotation and end up at the terminal arm. We would rotate through a point, xy, and the distance from the origin, which our initial arm is always started at the origin, would be r, distance from there to there. That r comes from radius, because we're visualizing that we are rotating about a circle. So, if I rotate, I'm going to draw my XY grid here. I am going to have my initial arm always here. I am going to rotate through the point root 3, 1. I have rotated and the x value is root 3. And my y value is 1. And if I have a ratio of root 3 and 1, I have rotated 30 degrees. Because I have an implied right angle triangle, my x value is a horizontal distance. My y value would be a vertical distance. So if I have rotated through the point root 3, 1, then I have created an angle of rotation of 30 degrees because I happen to know that ratio root 3 and 1 is 30 degrees. Sine of theta in this case is 30 degrees. Sine of 30 degrees we happen to know is 1 over 2. The distance from the origin to the point root 3, 1 is my r value. I can find that r value with Pythagorean theorem. This is going to get easier, by the way. R squared equals 1 squared plus root 3 squared. The distance from the origin to that point is 1 plus root 3 squared is 3. So r squared equals 4. Since I'm talking about distance, I just talk about positive numbers. So this distance is 2. I have a 1 root 3, 2 triangle created. If I have sine of 30 degrees equals a half, notice that 1 over 2 are the numbers for the y distance and the r distance. Cos of 30 degrees, I know that ratio. It is root 3 over 2. I knew that from yesterday, and looking at my diagram, root 3 over 2 is the x value over the r value. Let's keep these in mind. Tan of 30 degrees, I knew from yesterday, is 1 over root 3, which happens to be my y over my x. Sine of theta is y over r. Cos of theta equals x over r. And tan of theta equals y over x. When you're talking about an angle of rotation on the Cartesian plane, if you rotate through a point, x, y. Let's have a look at this angle of rotation. No, this angle of rotation. Let's do 60 degrees. We have an initial arm here along the x-axis, and we have rotated 60 degrees. And we are passing through the point 1 root 3. That means I have an implied horizontal distance of 1 and a vertical distance of root 3. I got those numbers from my horizontal x and my vertical y. I know this triangle. It's a 1 root 3, 2 triangle. Sine of 60 degrees is, knew this from the other day, root 3 over 2, which happens to be y over r, which is what we're looking at today. Cos of 60 degrees, we said on the last slide, is x over r. Let's look at our x value is 1, and our r value is 2. That is the same value that we figured out for cos 60 from yesterday. Tan of 60, our last slide, said tan is y over x. If this rotated through the point 1 root 3, that would be root 3 over 1. And it is true that the tan of 60 is root 3 over 1. Notice that the two examples that we've been talking about were both acute angles. So we're going to write down our observations, sine, cos, and tan, in terms of the Cartesian plane, angles of rotation starting at the initial arm through the x-axis, is, I don't want to lead you astray, so I keep looking it up every time, y over r, x over r, y over x. So let's find the primary trig ratios for 210 degrees. First thing I want to do is draw it. My initial arm is always here, and my angle of rotation is counterclockwise. So I am going to rotate 210 degrees. That's going to take me past that and have an angle of rotation there. That is my terminal arm. So there's my initial arm. There is my terminal arm. And there is my angle of rotation. I know that a straight line is 180 degrees. So I know that I have rotated 180 degrees plus another 30 degrees. So my 30 degrees is my related acute angle. And my related acute angle, RAA, there we are, is the angle that can help me draw a little triangle that can help me at least get started with this whole concept. 30 degrees means that I have created a triangle where the short length is a 1, the hypotenuse is a length of 2, and the adjacent side is root 3 from our observations of yesterday. So my terminal arm must have passed through a point where it is root 3 to the left and 1 down. So my angle of rotation has passed through minus root 3 minus 1 as a point. So sine of 210 degrees, which is y over r, will be minus 1, my y value. R is 2. So sine 210 is in proportion of minus 1/2. It is a negative ratio for an obtuse angle. That is always the case with sine. Cos of 210 is x over r. Our x value is negative root 3. R is 2. And tan 210 passes through the point minus root 3 minus 1 would be y over x, which is minus 1 over minus root 3, or positive 1 over root 3. Let's look at 135 degrees. We want to find the primary trig ratios for 135 using the special angles that we know or have in front of us. An angle of rotation of 135 degrees. Initial arm along the x-axis pointing in the positive direction. An angle of rotation goes counterclockwise, and 135 degrees is past the 90 mark. It's going to pass through there. Your angle of rotation, theta, is 135 degrees. We know our related acute angle is 45 degrees because I know I've gone 90 and then another 45. My related acute angle sits between the terminal arm and the x-axis. So I have 45 degrees right there. That allows me to find the point that the terminal arm has passed through. I know 45-degree triangles. I know that the proportion of the sides would be 1, 1, root 2, so that I know I have a left 1 and an up 1. That terminal arm must have passed through the point, left 1, up 1. Let's look at the three primary trig ratios for this then. Sine of theta passes through, and sine is y over r, positive 1 over root 2. Notice that your r value is always positive. Cos of theta is x over r. It is negative 1 over root 2. And lastly, tan of, and I should have been calling this 135 degrees, sorry, y over x is 1 over negative 1, or negative 1. I can change those to 135 degrees. There. Sine of 135 is 1 over root 2. Let's just check. Make sure that this is correct. Let's just solve it going backwards. See if we have done this correctly. If I want to know, sorry, I'm going to change my mind and look at the cos angle. There's a reason for that. But let's just look at the cos for a moment to check our answer. Cos of an angle is minus 1 over root 2. To find that angle, I would use second function cos on my calculator. Let's make sure we get 135 degrees. 1 divided by root 2. On our calculator, it is 135 degrees. Good. Notice that sine of 135 has the very same answer as sine of 45. Interesting. And if we go back one, notice that the tangent of 210 degrees is the very same as what we observed for tan of 30 degrees. Interesting. Okay. Let's look at one more. We're going to look at the primary trig ratios for 300. We're trying to get some new terminology into you right now. Initial arm, terminal arm, angle of rotation, related acute angle, and also the different signs and measures for these larger angles. Sine, so don't feel too overwhelmed. We're going to get through it. Find the primary trig ratios for 300 degrees. Starting my initial arm, angle of rotation through 90, 180, 270, all the way to 300 degrees. So my theta, my angle of rotation, 300 degrees. Initial arm, got these terms all down. Terminal arm, my related acute angle is in here. It's always between the angle of rotation and the x-axis. And that angle of rotation, if you can do your adding and subtracting carefully, is 60 degrees. That will allow me to find the point that this passes through. I know for a 60-degree triangle that I have the ratio of lengths here of 2, longer side root 3, shorter side 1. So 60 degrees, I want my 3 ratios. It would be very helpful if I knew a point that this terminal arm has passed through. That point would be 1 to the right and root 3 down. So if sine is y over r, then sine of 300 is minus 3 over 2. Root 3 minus root 3 over 2. Cos of 300, which is x over r, is 1 over 2. Tan of 300, which is y over x, is minus root 3 over 1. And again, strange observation. Notice that the cos of 300 was the very same answer as when we did cos of 60. One ratio that's the same on this particular slide, cos 60 is positive 1/2. Cos 300 is positive 1/2. It is an interesting observation that the cos of theta is equal to cos of 360 minus theta. Let's go back a slide. The one that was the same was sine of 135 to sine 45. Sine of theta is the very same as sine of 180 minus theta. And lastly, the ratio that was the same on the first example that we did was tan 210 and tan 30. It is interesting that tan theta is identical to tan of 180 plus theta. There is something that we've made note of today. You need to write that down. The other thing, maybe we should add it to this slide. Sine theta equals y over r. Cos theta equals x over r. And tan theta equals y over x when we're talking about angles of rotation on the Cartesian plane. First example here. We're almost done. If sine theta equals root 3 over 2, find theta. And this means we're talking about angles of rotation around, basically around a circle. There might be more than one answer. We know that when we had a positive answer before, we found a same positive answer in an obtuse angle. If sine theta equals root 3 over 2, we're going to use our calculator to find the first answer. We're going to do second function sine of both sides to find the first answer. Or we'll look on our chart and know that theta is 60 degrees. That would be this angle of rotation right here. But there is another angle that would also give you root 3 over 2 as your ratio for sine. And that would be 180 minus theta. (120 degrees). To check our answer, we're going to do sine of 120 degrees and make sure that we get root 3 over 2. Let's compare left side and right side. Sine of 120, which is root 3 over 2, is 0.866. Root 3 over 2, just checking. Root 3 divided by 2 is indeed 0.866. So both sine of 60 equals root 3 over 2 and sine of 120 equals root 3 over 2. And I got it from this. If tan theta equals minus 1, find theta. We know the answer to that. That's one of our special angles. But we're going to solve it by doing second function tan of minus 1. Our calculator gives us the answer, minus 45 degrees. Well, minus 45 degrees doesn't fit there. So I have to translate that a little bit. Minus 45 degrees is an angle of rotation going in the wrong direction. So it would be an angle of rotation going this way, 45 degrees. So giving it a positive answer would be an angle of rotation going counterclockwise this far, which would be an angle of 315 degrees. So one answer to this problem is 315 degrees. But there could be another angle that gives us the same ratio of minus 1. And I get my second angle of rotation from looking at tan. And my second angle would be 180 plus, and I can use either answer, this one or this one. and I will get another angle that will give me the same value of minus 1. 180 and negative 45 is 135 degrees. Let's check on our calculator that both of those are true. Is the tan of 45 degrees equal to negative 1? Tan 45. Sorry, my bad. Tan of 315. Did all that translating for nothing. Tan of 315 degrees is minus 1. And tan of 135 is also minus 1. So we need to use this and these. And you only have a few questions on page 292, but I would also like you to finish filling in the chart on that handout 1-3.